I'm Anil Kumar, and in this video we'll try to understand rate of change for a trigonometric function. Diameter of a monster truck tire is 3.5 meters and it makes one rotation in every 5 seconds. What is the average rate of change in height of a point on the tire for the first 1 second if h of 0 equals to 1.75 meters for that point? Assume that the tire is going to the highest point. Okay, so in this case, let us consider that this is the monster tire which we are talking about. And what we have here is, let me just make some guidelines. Okay, now what we know about this tire is that it has 3.5 meter, okay, diameter is 3.5 meters. So this diameter is 3.5 meters. That is given to us. And it makes one rotation in 5 seconds. Makes one rotation in 5 seconds. What is the average rate of change in height of a point on the tire for the first second if h of 0 is 1.75. So 1.75 is midway. So let us say this is the point for that point, right? Assume that the tire is going to the highest position. So we are assuming that it is moving in this direction. So the point is moving towards the highest position. So this is given to us, and this height is 1.75 from the ground. Okay, so that is what is given to us. And we need to find the average rate of change from this position to the position after 1 second. Now the question is, how do you find the position after 1 second? That's a critical thing, right? Now, with reference to the initial point, what we can say is that one rotation takes 5 seconds. So in 1 second, what part of rotation will it take? In 1 second, we'll have rotation of 1/5, right? 1/5 of a circle. In 5 seconds, it is one full rotation. So in 1 second, rotation is 1/5 of the circle. Now when we say 1/5 of the circle, then the angle will be how much? In that case, theta should be equals to 1/5 of 2 pi, correct, in radians. So what we can do is, we can assume that from the center, the point is somewhere here, where this angle for us is 2 pi by 5. You get the point. So that is the angle which the point will be making with the center. And we know that the radius is 1.75. Correct? So that is the radius. To find the distance, we can assume a new reference frame, and that is, we can think about the axis kind of like this. Okay, now here what we will calculate now is the height of the point above the center line, the axis. So this height, let it be y. How much is this height? From this triangle, let me say OPQ, we can say that sine of 2 pi by 5 is equal to y over 1.75. And so from here we can calculate this point's height with reference to this line, correct? So the height y will be equals to 1.75 times sine of 2 pi by 5, right? So let me use the calculator to calculate this particular answer. So we get 1.75 times sine of, within brackets, let's write 2 times pi divided by 5, bracket close, equals 2. So we get 1.6643. So we get 1.6643. So that is the y value of this point, correct? Now we know the time difference between these 2 points is 1 unit, correct? Now average rate of change is what? We can write here average rate of change is equals to change in height over change in time duration. With respect to time, we are saying change in time duration, right? So in this particular case, the change in time duration is from 0 to 1 second, right? So it is 1 minus 0. We are assuming this height to be 0. I mean, it is given 1.75 from the ground, right? So you can use 1.75 from the ground. In that case, this height will be y plus 1.75, correct? Anyway, the difference between the two is 1.66. The change in height is 1.6643, right? Therefore, the average rate of change will be 1.6643 and the units are meters per second. I hope you get the concept. So that is how we can find average rate of change for a point on this wheel after 1 second, in the first second. Okay, so that is how it should be done. Thank you and all the best.